Welcome everyone to this morning's session, the first of the day. For those that are in the earlier time zones, good morning. For those that are further over towards the rest of Asia, very good morning to you. Thank you for getting up so early. My name is Nathan Weed, as Pauline's introduced, and although I work for AWS, my role is to look after the relationship with VMware, a suitably hybrid role for a hybrid conversation. And this morning, as Pauline's already introduced, I'll talk about how we can use the VMware Cloud on AWS offering to build modernization into applications that you may already have on a VMware-based environment, and in fact may have been in your enterprise environment for 10 or more years. We can use this service to bring modernizations to that environment. But let me start with a bit of an introduction about where this relationship has come from. It's still reasonably recent. In 2016, VMware and AWS announced an intended partnership, and then a year later in 2017, we first released to market the VMware Cloud on AWS service. Now, this is a deployment of the VMware operating system, the vSphere hypervisor, along with vSAN for a storage layer and NSX from a network infrastructure layer. It's deployment of that software stack inside the AWS global infrastructure. It's fully compatible with what you would have on site if you're a VMware customer today. So in your data center, you may have VMware vSphere deployed on top of server hardware that you own, and storage that you have inside your facilities, and vCenter is your management console into that. The same software stack is used in the VMware Cloud on AWS service, and you can link it to your on-premises environment via hybrid linked mode or a newly announced vCloud Gateway service. And this allows you to, as a customer, to manage virtual machines and hypervisor hosts from the one console, so one pane of glass to manage the combined environments. You may notice, if you're very familiar with VMware, that the software stack in the AWS-based service is VMware Cloud Foundation, which is a hyper-converged software stack. On the right-hand side of this diagram, we've also got available to the service all of the 120 plus AWS cloud services. And there is a linkage provided between the two capabilities, the VMware Cloud and AWS, and everything else that AWS already does and may do in the future via an elastic network adapter. And I'll talk about that in a bit more detail. And that's really the basis of how the AWS cloud services can bring new capabilities into existing applications. So looking a little bit more closely at the service itself, we are deploying a VMware vSphere hypervisor on top of a bare metal instance. In this case, it's an i3 bare metal compute platform, and we install, or VMware installs, the vSphere software natively on top of that hardware. So it's not nested on top of another virtualization layer. This is the same deployment of vCenter and vSphere that you would have in your existing data center. Straight on top of the bare metal hosts that are provided by AWS. As you can see, we've got 36 cores inside each node, half a terabyte of memory, and about 10 terabytes or 16 terabytes, I should say, of raw device capacity, but that translates into about 10 terabytes of used space as you build that cluster up. The storage is provided by local devices in each node, and that contributes to the vSAN data store layers. We won't go into great detail about the architecture in this particular webinar, but on top of the platform are the same vSphere features that a customer might enjoy inside their existing data center, such as vSphere high availability, vMotion, dynamic resource or distributed resource scheduler. And there's actually a new feature called Elastic DRS, which can automatically grow and shrink the cluster itself as the workload demands increase and decrease. And in highest importance for this application modernization based webinar, there's a networking layer which is 25 gigabit based adapters that are essentially exposed to the AWS side of your particular environments. Where are we seeing the use cases? It's around these three leading types of deployments. The first type of use case that we're seeing, and when I say first type, it's about 40% of the interest that we're gathering from the global deployments. They're centered around cloud migrations, which includes customers that are exiting their data center facilities completely. As has been said a long time in the past, friends don't let friends build data centers. A lot of customers are now turning to cloud-based services as an alternative to running their own infrastructure. And the VMware Cloud and AWS service allows that exercise to take place without making dramatic changes to the applications and the application architecture that they already have on premises with their VMware-based environment on site. Other types of cloud migrations might be reducing the number of data centers that a customer has from many around the world down to a few core locations, and then everything else being delivered via cloud services, or it might be major applications that are exiting the data center facilities. The second use case, at about 30% of deployments around the world that we're seeing, are extensions to an existing data center capability. And particularly this is where customers already have an investment in their existing data center and their infrastructure that needs to continue to serve its purpose for a fair period of time, but there are new needs coming along all the time. And those new projects, that extra capacity and demand, the business is deciding not to serve that through putting more capital and more investment into the existing facilities, but to expand that out to VMware Cloud on AWS. And that might be purely test and development workloads. It could be expansion to other geographic regions, or it could be that there is new application deployments that just require capacity that the business is not willing to invest additional growth into. And the last use case, at about 15 to 20% of the global deployments, are disaster recovery. And in some ways, this is an easy place to start for some organizations because they can shut down their secondary or non-production data facilities, their data center facilities, and have disaster recovery served out of a cloud-based operational costed service, as opposed to investing capital and unused or underused hardware into a data center which is effectively not used at all. Again, there are many ways to make that scale on demand and reduce the overall cost of serving disaster recovery, which won't be the focus of today's session, but we can go into in future sessions. You may have heard about a month ago at VMworld, there was an announcement of the first availability of the service in the Asia Pacific region, and that is the Sydney region for AWS. And that is the 5th iteration of the service. So there are now 5 active regions for VMware Cloud on AWS, now including Sydney. And as you can see up on the top of this particular slide, all of the rest of the regions around the AWS global infrastructure have been announced with timeline indications. So we have, instead of each new cycle of release going to a particular region, as has happened in the last 5 releases so far, the next few releases are going to incorporate multiple deployments around the world, and the availability of this service will greatly accelerate from here on. So that's great news for customers and users that will be coming from the other Asia Pacific locations. We have Japan, Korea, India, I think, up on that list, and Singapore as well. So they'll all be coming online very shortly, which would be great news, with the goal that all regions will be covered by the end of 2019 or thereabouts. So what's new in the service? And this is a reflection of the announcements that happened at around about the VMworld timeframe, same as the announcement about the regional availability. One of the capabilities was introducing vSAN backed by AWS Elastic Block Store volumes. And this addresses one very common piece of feedback from customers, is that the service up until that point had provided storage from the inbox service, the devices, and some customers, quite a few customers, had storage well in excess of what was available on those local devices. And so we, as AWS and VMware, responded to that interest and demand by integrating the VMware Cloud on AWS service more directly with EBS to allow customers to expand their choice of storage and their choice of capacity per node using the flexibility of EBS. The other highly interesting announcement out of this was that the minimum cluster size was reduced from 4 nodes down to 3 nodes, and this opens up the entry, or lowers the entry point for customers getting on board onto the service, and also opens up the possibility for smaller customers with fewer virtual machines to take advantage of the service in an economical way. There was also an announcement of full connectivity integration over AWS Direct Connect, and associated with that, full integration with the next generation version of VMware's NSX network virtualization platform. Both of those aspects allow customers to integrate the VMware Cloud service and their application connectivity over Direct Connect, so both the management, administrative traffic, but also the virtual machine workloads, but also the integration of some of the advanced NSX capabilities, such as micro-segmentation, distributed firewalling at the per instance level, and distributed logical routing, and a few other features as well. So that greatly enhances what a customer might have on their VMware environment today by automatically making available some of the advanced NSX security services that customers may or may not have in their existing facilities. We also announced integration with AWS Key Management Service, and this is a way to provide cryptographic protection for the vSAN data store, which was encrypted anyway. However, some customers in certain highly protected industries wanted to be able to do the policy-based key management themselves. And so there was already a ready-made service in AWS KMS to support customers in rotating their encryption keys, so at all times maintaining the security and confidentiality of the data that they put in the platform. Now let me start talking a bit more about the integration between the environments. And for starters, there's 2 different account structures behind the service. The first is that this is a service that's sold, supported, and operated behind the scenes by VMware themselves. And so in association with the VMware cluster, there is a VMware Cloud SDDC account that lives within the AWS environment, but is behind the service that operates a particular customer's VMware tenancy. And this is owned and operated and billed by VMware to the customer. So as a VMware Cloud on AWS cluster is deployed, the bill will come from VMware, and it's coming from an account that is managed on behalf of the customer, but by VMware themselves. Now, when that environment is deployed, there is an associated AWS account that is already in existence, and that link is created on deployment. And this is where a customer can connect what they're already doing in AWS native services with that VMware environment. And so that will be requested and associated on the first creation of the VMware service, so that the customer has control over what native services they make available to the VMware environment, and that consumption of resources of the AWS services is then billed by AWS directly to the customer. So you'll see that there are a combination of services, some from VMware billed by VMware, and some from AWS billed by AWS. And they'll both go to the customer, and that will provide at least some integration between what is happening on a per application basis on two different modes of operating your environment. Now, I made reference to the linkages between those environments technically. So here is an example of what happens during the deployment of the VMware cluster. So a customer will go to the VMware Cloud portal, which is found at vmc.vmware.com, and that will be the process through which a customer will create their vSphere cluster. And at that time, there will be a template made available to the customer to run within their nominated AWS account to give very limited access to the VMware environment to manage things inside that AWS account on your behalf. And part of what's going on there is associated with the network integration, which I'll just do on the next slide. So there is activity. The point of this cross-account role here is to create the ability for VMware's automation services and also the changes that are associated with the environment over time to be synchronized with the AWS account that is in the customer's hands, so that it reduces the amount of ongoing operational effort and makes sure that the environments are able to communicate no matter what changes happen on the VMware side of the fence, such as increasing the number of hosts in the cluster or replacement of any failed hosts and so forth. But let's have a look at an example of how that's used in this diagram that shows the way that the networking integration is achieved. So on the left-hand side, you can see the VMware Cloud on AWS account that's managed by VMware. There are, in this particular case, 4 vSphere hosts deployed in a cluster, and there is a node associated with those with that particular environment called the Compute Gateway, CGW, up on the center of the left-hand side there. And that's the networking path through which the virtual machines can talk to the outside world. Now you can see from each host, there is a dotted line over to the customer-owned AWS account, and these are the elastic network interfaces that are exposed in the customer-nominated VPC subnet on the right-hand side. Now, the cross-account role that I explained on the previous slide manages the route table between the two environments. So on the far right of the diagram, there's a route table which exists within the customer's VPC environment. And that is there to enable the AWS side of services and maybe EC2 instances to find the VMware logical networks and the virtual machines that are on the left-hand side, the VMware environment. Now that needs to be managed by VMware automation, because let's go through a scenario. Potentially a vSphere host gets taken out or put into maintenance mode, or the cluster size gets reduced. That compute gateway will then relocate itself or become active on the next host in that cluster. And because it's the network path is happening through a different elastic network interface, the VMware automation scripts will update that route table to redirect the traffic seamlessly to the right interface, so that there's no loss or downtime of communication between the environments. And that entire process of removing a host from the cluster is done in a controlled manner and very proactively, unless it's a catastrophic failure, such that the routes and the movement of the compute gateway are done in advance, so that the whole process is managed end-to-end on your behalf. Now, as a customer, you wouldn't see any of this mechanic happening underneath the covers, but it's to explain the purpose of that cross-account role and the interaction that's already being enacted for you to take advantage of using the services for a given application on each side of this fence, of this hybrid environment. So let's go through a particular example of what you might do as a customer, and we'll use an example of a general use case, a customer wanting to expand their existing data center capacity. They want to use the VMware Cloud service for moving certain applications over to AWS, given that it's already VMware based, but then there are certain things that need to be met. And so, for instance, in order to take advantage of the hybrid cloud capabilities and to meet the business's governance needs and protection needs, there are certain things that need to be achieved. And in that case, it would be these 4 use cases on the right-hand side here. So the first step to doing a hybrid integration between VMware's on-premises environment and the cloud-based service, we want to have a seamless migration experience and minimize the amount of downtime and the disruption to the business by moving applications between the two. The second is to look at now that we've expanded the capabilities of the business over to a cluster sitting on VMware Cloud on AWS, how can we now expand an application's scalability and performance by using some of the AWS native services? Thirdly, what are the backup and disaster recovery capabilities that might be brought to applications that are in that environment? And then lastly, and this is where we start to really get into some of the hybrid services, how can we ramp up security for a given application using some of the awesome features in AWS? And we'll talk about some of those, such as AWS Shield and Guard Duty, to provide a layer of protection over things that already exist in a customer's environment, but with minimal effort and really stepping up the degree of protection and monitoring that an application has without making those dramatic underlying changes to the application architecture. So let's start through this process with seamless migration. There was a capability discussed at VMworld, and it's been around since the inception of this service under 2 different names. So you may hear it now talked about as VMware NSX Hybrid Connect. It's also concurrently called the Hybrid Cloud Extensions, HCX. It's the same tool, just undergoing some rebranding. But the NSX Hybrid Connect tool allows customers to do bulk migrations and seamless connectivity between 2 environments. And in this case, those 2 environments are an on-premises data center and the AWS-based VMware service. The first thing that is delivered by this seamless connectivity is an extension of the networking layer from the existing customer data center over to the AWS-based service. And this is a layer 2 VPN, so extending an existing VLAN segment from the data center over to AWS. And that is behind the ability to do things like vMotion, migrating live virtual machines from one side to the other without changing the network addressing, without changing the routing and the config rules associated with virtual machines. And that can go in both directions. The other thing that was announced is being able to move the services on bulk. And so there was a capability which uses vMotion in conjunction with replication technologies, vSphere replication, to do massive migration of thousands of virtual machines in a managed fashion from one side to the other. And that was called Cloud Motion. And the demonstration of that was selecting many hundreds of virtual machines at once, commencing the replication, and then the vMotion exercise is timed and scheduled so that the movement of applications between the 2 environments can be done in a coordinated fashion between the 2, and also managed via replication technologies, because the movement of data is really the very time-consuming part of this. The next thing that was on their list of business requirements is having access to scalability and performance improvements at an application basis. And so one of the common discussion points is, how can an existing application extend its storage capabilities over to some of the much higher scale and lower cost services from AWS, such as a simple storage service or elastic file system, to move some of the bulk amount of data away from heavy infrastructure and onto tiered data center data services. And so in this case, you might take an existing application which has many terabytes of reasonably cold data, such as huge file systems that may have a lot of legacy information which hasn't been managed or just needs to be retained a long time, but doesn't need to be stored on highly performing vSAN infrastructure. And a lot of that data can be moved out to lower cost S3, for instance, or EFS, which is using S3 under the covers, and use lifecycle policies to move that data down into lower and lower cost tiers of storage to take advantage of the most appropriate place to manage and store that information over time. And this is both a way to massively scale the data footprint of what a customer might have in their applications and in the data center today, but also introduce a huge amount of economical benefit to what would normally be purchased on site with a large SAN capability, for instance. And this is a different and more nuanced way to store data using cloud services that are available, but may currently be distant from a customer's data center. And this is exposed to the VMware Cloud capability via, as you can see on this diagram, I hope my mouse comes across over here, we have the compute gateway, which is exposing an interconnectivity service with elastic network interfaces into a VPC. The S3 service can also be configured to be exposed into the VPC privately via a VPC endpoint. And then through that chain of private connection points, we're able to expose the S3 service or Amazon EFS to an existing VMware application without going over network paths on the internet and without creating new security vulnerabilities or new security threats that the business needs to start adapting their policies to take into account. Another way that you might introduce scalability and performance improvements for an existing application is to take advantage of Amazon RDS. So this is the relational database service. And this is really getting into the first step of how you might transform the applications themselves into higher level services from Amazon Web Services. So we've had hundreds of thousands of customers taking up RDS. It's been well established for a long time, supporting databases from Microsoft SQL Server, Oracle, MySQL, Postgres, MariaDB, and one of the more interesting ones recently is Aurora, which is AWS's own database format. And this allows organizations to maybe escape from very expensive and very hard to manage database platforms and really just get back to the business of managing the databases themselves, which are used by the applications. So being able to move an application footprint over to RDS, again, exposed through the elastic network interface between the environments, which is very high speed and very low latency, so 25 gigabit connectivity and almost minimal latency between the two, because these are deployed both in the same availability zone and both in the same AWS infrastructure, so that applications can be joined to RDS services and very rapidly decrease the amount of effort that's required to manage a given multi-tier application by moving just one of those tiers over to the AWS native capabilities. And those that are familiar with RDS will know that you can go into the service and manage the scale of RDS deployment over time and dynamically, so that the whole exercise of managing capacity for a database is hugely simplified and becomes the output of what AWS is delivering on your behalf, as opposed to having to dedicate your own staff time, skills, and effort and pain into managing and scaling the database platform itself. And then from a networking perspective, this is where it is quite easy to enhance the capabilities of an existing application through adding networking services. And now, just to be tricky, we've reversed the order of the AWS account and the VMware account here. So in this diagram, the VMware Cloud on AWS account is on the right-hand side, running a collection of virtual machines that are serving a common application. And so instead of running what might be used today in a data center, which would be a physical load balancing appliance from the well-known vendors, but costing additional money in terms of hardware, licensing for capabilities inside the data center, and support contracts, and also just having another vendor to manage. You could replace that layer of load balancing capability with the application load balancer from AWS. And this would introduce and open up the path to doing deeper transformation of the network and security services that you would put in front of an existing application that's VMware based. And so we'll talk a little bit more about that, but here you can see an example of an application load balancer configured with a target group of IP addresses, which are on the text of the far left-hand side, and that group of IP addresses would actually point back to the virtual machines, the vSphere-based virtual machines that are exposed through the connection to the VMware cluster inside of AWS. And I'll build on this example in a little bit more details. You'll see that this gets built up more and more as we go into the example that I'm about to show a bit later on in the session. But before we get into greater detail, let's have a look at the methods that are available to do backup and disaster recovery. And really, there's not one answer that's going to serve all purposes. So the initial conversation that I'll have with the customer is what level of protection is appropriate for them and for each application that's inside the environment. And the most successful strategy that I've seen from numerous customer stories is maybe using a couple of strategies to protect a collection of applications, because not all applications need to be protected and recovered the same way. So on the far left-hand side, there are lots of applications which are less mission critical, less business critical, and if the if the environment or if that particular application can withstand an outage of maybe hours and even a loss of data of hours, then you might just use traditional backup and restore capabilities from your traditional backup approaches. So maybe a 24-hour cycle of backup and restoration, if that's what's in place, but you could also use higher rates of backup. So maybe every 8 hours or 4 hours, backing up data to S3, and then therefore doing a restoration of those services from an object store. The other examples here, as we get on to more highly critical restoration times, are going to be based on varying degrees of having the VMware environment available. So the first might be you stand up a pilot light environment. So this is where you would have a VMware cluster sitting in a disaster recovery ready state, but in a very small footprint. And so the basic network connectivity services are there, maybe a virtual machine providing Active Directory authentication services or something along those lines, very basic infrastructure services running on the disaster recovery cluster. But then as the disaster recovery event takes place, the workloads get turned on from a replicated state, and the capacity of the VMware-based cluster can be expanded on the fly. Now, this is where the recovery point, so the data being protected, might be replicated quite frequently, but the recovery time can take a little bit longer. And that little bit longer means that there might be some critical services done in the first few minutes, and then as the cluster expands, which takes 10 to 15 minutes per node to add to the capacity, you can add more and more services and restore more and more capability, but in a controlled timeline over maybe a few hours. And then on the far right-hand side, at the most expensive option, you might just have a fully capable VMware environment, receiving all of the data being replicated down to seconds of changed data blocks being replicated from on-premises to the VMware environment or between VMware Cloud on AWS regions. And the recovery time is either real time because applications are running in both environments concurrently, or you might use VMware's site recovery option, to do a controlled restoration of services using a disaster recovery plan. And so the customers that I've seen successfully deploying this and with a solid business case will use a little bit of each approach up here to provide fast restoration for mission critical services and then slower restoration processes for things that can actually take that slightly longer time to restore back to service. And that means that the overall cost of delivering service to the business is managed appropriately. So here's an example of how you might introduce backup services as a part of the hybrid architecture for a given application. So on the left-hand side, you've actually got an on-premises environment with virtual machines being backed up through an on-premises backup server. That backup server may have direct AWS S3 integration, or it might go through an AWS storage gateway to provide CIFS or NFS or other types of storage capabilities that the backup server isn't aware is going over to a cloud service. And so the backup server would, through one means or another, back up the data through the AWS Direct Connect service that they might have for that kind of high data throughput over to an S3 target bucket. And then on restoration of the services could be restored into a VMware Cloud environment, again using the backup server to manage the restoration process. But in this case, the target would actually be restoring virtual machines as they were backed up into a new vSphere cluster running on a cloud-based environment. And so that is an example of using the low-cost backup and restore process to get environments or getting disaster recovery capabilities for an existing on-premises environment, but fundamentally in a different way. Another capability that is available at the click of a button is using the stretched cluster capability of VMware Cloud between multiple availability zones. So this isn't done by default. It's something that you can choose to do as a customer, and that is when a cluster is deployed, it will deploy equal numbers of vSphere nodes on two different availability zones to provide for a very high amount of availability for your VMware environment. This uses the synchronous replication that vSAN can provide by stretching its data store between two different locations. So it has location awareness at the storage layer and very specifically makes sure that data is synchronously stored and kept in sync between the two different locations. It does mean that you replicate the amount of data and therefore you double the amount of resources that you're consuming in a cluster like this. But if this is one of the many deployments that you might have, there are mission critical services that will benefit from this and that are appropriate to put on a stretched cluster, but without putting any engineering effort behind the infrastructure itself. Now this is as compared to doing a stretched cluster between two on-premises environments. The engineering effort to go into the networking and the storage layers and the coordination of capabilities between two different physical environments is actually quite it's quite detailed and quite involved, and the expense of setting this up in a traditional on-premises environment is reasonably prohibitive. Whereas using VMware Cloud on AWS, you can just simply click a button when you deploy a cluster that says, yes, I want to stretch this environment, and the only consideration is whether the business is willing to pay the extra to have the capacity available in the availability zones in this way. As I mentioned before, there's also the availability of VMware Site Recovery to protect virtual machines in the same orchestrated fashion that has been done traditionally on premises between two data centers. And this can protect workloads that are running on premises to fail over to VMware Cloud and AWS. It can also be used to fail back from VMware Cloud and AWS back to on-premises. So the virtual machines don't change formats between the two environments, and it provides a very cost-effective and highly simplified way to provide disaster recovery with no double conversion of virtual machines between two different environments. But we can also use the site recovery service to protect between two different deployments of VMware Cloud and AWS. So for instance, you might have a cluster deployed in Sydney, which is your normal production VMware environment sitting in the Sydney AWS region, and you could set up site recovery to do replication and orchestrated disaster recovery planning to maybe a US region, just in case you needed to shut down the environment, or in case there was some kind of catastrophic outage on a network services side of things, or the God forbid your cluster becomes unavailable. So this provides disaster recovery capabilities using any combination of on-premises, cloud-based services, and in both directions. And again, this is a familiar technology that's been available from VMware for about 10 years. So many customers will already be using this disaster recovery approach in their environments today. So circling back to modernizing the applications themselves, I'm going to build on an example where we use the on-premises application environments protected by application load balancing. Now, in this case, I've extended on the left-hand side purely scaling applications using application load balancer to now introducing some AWS native capabilities for protecting that application. So in this case, we would have the front end of the application being cached and available through AWS Cloud Front, which is distributed to multiple edge locations around the world. The access to that application is managed by AWS Route 53, and AWS Shield is enacted to protect the application from internet-based attacks. So generic attacks on any internet-facing application are common, and AWS Shield is sitting there as a high-level service looking at the interaction between services that are deployed in AWS and the rest of the world. And more specific to the application, it would be highly recommended to look at services like the Web Application Firewall to provide advanced firewalling capabilities in front of your application. And in this case, we'll build on that a bit further in the demo that I'll run. Going a little deeper into the application itself, you could also provide compliance management and configuration management inside the virtual machines and inside EC2 instances that you might run using AWS Systems Manager. And this is a way to provide desired state configuration through a code-based configuration management approach. And this is where you might use desired state configuration descriptions to say that you need certain packages, certain capabilities of the operating system, or certain files present for an application layer to be installed, present, running or not running inside the environment. And you can use AWS Systems Manager to run compliance scans to tell you what is currently in compliance with your stated configuration and what's out of date, and also potentially remediate the environment or point to environments that need to be remediated, and have a very quick dashboard on the state of the environment. Unfortunately, I don't have that one queued up to demo today, so my demo today will show application protection for an internet-facing customer application. And in this case, I'll use a combination of services for an application that are deployed on premises. So on the far right-hand side of the diagram, we have two instances of the application for a customer environment sitting on the VMware Cloud on AWS environment. And just to show the hybrid expansion here, we've got an application, a third instance available inside AWS VPC itself. And so a customer can have their request served by either an instance running inside of AWS or the virtual machine instances running on top of vSphere. An application load balancer, in this case, I'll show you, it distributes traffic between those three environments seamlessly. And again, that connectivity is enabled through the VMware provided elastic network interface between the two environments. I'll build on that a little bit further. We'll use VPC flow logs that collect information about the network traffic that goes in and out of the application, and we'll combine that with information coming from the application or the AWS web application firewall, and have the output of the rules and the either warnings or issues or flow logs being dumped into an S3 bucket. And that S3 bucket is having Lambda rules done on the raw data to transform that into information which is stored in a long-term S3 bucket. And we'll use that S3 bucket to do a deeper analysis and visualization of as Amazon Elasticsearch and Kibana to provide the visualization. So you'll see a little bit more about what I mean as we go through the demonstration. And I'll also incorporate what we would see in terms of the protection of the application from AWS Shield and from Amazon GuardDuty for those that maybe haven't seen those services run. So with that, I'll flick over to the demonstration environment, and bear with me while I change screens. So here is a representation of the exact same diagram that I've gone through. And we'll start this demonstration off by showing the configuration of the application load balancer that's distributing the data. So here is the DNS name that's in front of the application load balancer. It is internet facing, and we've deployed that ALB across 3 different availability zones to run in a given region. We've configured one HTTPS listener on port 443, and we've got certificates being provided by AWS Certificate Manager and forwarding rules that are distributing the traffic. And in this case, we've actually got 3 forwarding rules. Just for the sake of demonstration, if a user requests a specific instance of the application, it will be forwarded to the application in the VMware environment or the AWS environment, and that's just for our purposes of demonstrating here. If we look at the target group configuration, we have targets configured for one of the target groups here, and in this case, it's a single instance of a virtual machine running in the vSphere cluster. The next layer that we look at here is the Amazon CloudFront distribution, and this is here to distribute the more static content and the user, the first point of contact for the user, into the AWS global locations. So in this place, we've configured all locations to be available. We have a web application firewall configured with the ACL there, and the SSL certificate, as mentioned before, provided by Certificate Manager. If we look at the configuration of AWS Shield, now this is available for all customers by default at a simple level, and advanced can be turned on for customers selectively. We can see that here in AWS Shield, we have protection of internet-facing services. Some are being monitored from a network perspective, and some are more specific instances that we can see. And we've got a visualization here of the types of attacks coming from the internet to all internet-facing services and the nature of those attacks. In the web application firewall, we have a rule set called Demo1, which is protecting the application that lives in the VMware and the AWS environment. And the rules that you would create there would be the same as you would have for a traditional firewall, except that in this case, it's protecting a hybrid deployment across 2 different environments. And as I said, there are the outputs of those going off to S3 for analysis. Amazon GuardDuty, AWS GuardDuty is looking more at the inspection of things like unprotected ports, the configuration in more detail about your particular environment, not just internet-facing exposure. So here we have a particular specific instance where port scanning is taking place and the SSH port is open, and it's showing us that particular vulnerability or threat has been scanned by an internet-facing actor, in this case coming from the China geographic region, providing recommendations to protect it. And the last area here is we've got the the flow logs and the web application rules being distributed to Elasticsearch for analysis. And we'll do the visualization using Kibana. And now Kibana here, we can look at different aspects of the type of data being tracked and visualized. So here we have Cloud Trail showing the source of configuration changes for the application stack. We might also look at the general flow logs to find where information or where the network traffic for the application is coming from, and we can see that's pretty well distributed around the world. And we might also see where are we seeing load balancer activity, and that's in certain edge locations and regions around the world. So very specific points of entry into the application itself. We might also look at the combination of services, like where are we seeing console logins for Cloud Trail tracked activities. And we can see that there are only 2 regions around the world. And then lastly, we can have a look at where has the SSH activity being generated from around the world. And then lastly, the relationship between security groups and the types of rules that we have configured in our web application firewall. So we can see a pie chart here showing a number of security groups that are protecting our web application and the types of ports and services that are being protected by each of those security groups. And so this is a great way to introduce visualization for an existing application using the services that are readily available from AWS. We saw Shield and Guard Duty, which are very easily configured and turned on for the environment at very minimal costs. And with all of the traffic about the network flows, the web application rules and so forth being piped into an S3 bucket for analysis, we can use Kibana to provide the visualizations of what's actually happening from a security perspective to this application over time. And again, this is without changing the architecture and nature of the application itself. So in summary, what I have gone through in this session is to address some of the key business requirements behind the data center expansion use case, but more particularly the kinds of considerations that from a business would need to be thought about and addressed in expanding the hybrid deployment of applications from an on-premises environment over to VMware Cloud on AWS as an extension to that on-premises VMware environment, but also the combination of AWS native services to extend the capability and to start to modernize the application layer by layer, component by component. First step in this was looking at the seamless migration options to move the existing data center workloads at the virtual machine level from one side of the environment to the other. And we looked at the NSX Hybrid Connect to do that migration experience using live migration and extension of the layer 2 network. We also had a bit of a look at how we might introduce extra scalability and performance improvements for an existing application using services such as Application Load Balancer, the Amazon Relational Database Service, and EFS to provide data tiering and extension for what would be done at the data layer. From a disaster recovery and backup perspective, we looked at a couple of different techniques there. So one using Amazon S3 to provide backup and restore capabilities inside the cloud, but also the usage or the reusage of VMware Site Recovery to protect environments between on-premises and cloud, cloud back to on-premises, and even cloud to cloud. And then lastly, getting into the more complex use case, using the secure protection capabilities of AWS network and security services, such as Route 53, Amazon CloudFront to provide distribution of a web application to as close to the user as possible around any geography. Web application firewalls, AWS Shield. We also looked at Guard Duty and visualization of the analytics that are going on behind the security services protecting a given application. How to get started? My recommendation follows the path of these 4 points here that I've got on the screen. So the very first thing that you might need to do from a business foundational perspective is to look at the online sizing and TCO modeling of running up a VMware clustered environment. So presuming that there is an existing desire and intention to extend your capabilities over to AWS and to cloud-based services in general, to look at the cost of doing so, and you could even use VMware Cost Insight to provide a free migration assessment based on the workloads that you're looking at, and measure the resource consumption and spit out a scientific TCO as opposed to the paper-based TCO that you might run using the online TCO tool. There is a single node starter configuration available at very low cost. That's available in the Sydney region and in any of the regions where this service is offered, and that is limited to 30 days because it is a single node and therefore doesn't have the redundancy of a production cluster, but it has all of the other features that are available for VMware Cloud and AWS that you can spin up with just a credit card, pay by the hour for as long as you want to test out certain features and capabilities, but deploy a given application onto the environment to see for yourself whether you can do the integrations that you're looking for. It will have the ability to connect up to your AWS native VPC and the services you might expose. And this is a great way to just get started. Just start experimenting and innovating with the account, with the applications that you've got on premises. Move some of those to the environment, and then at the end of the process, you can move them back. Or at any time during that 30-day period, scale it up to a production VMware cluster on the AWS service. And then lastly, if you would like any assistance whatsoever, please do reach out to your AWS or VMware specialist teams. There are staff employed by both organizations that are purely focused on this VMware Cloud on AWS service, and we would be more than happy to discuss with you any of the aspects that we've covered on the webinar today. So for further resources, there are public websites available both through AWS and through VMware. So the linkages are provided up on the website here. I encourage you to have a look at those, plus also the public videos that are available on YouTube. And these are inclusive of the reInvent 2017 breakouts. And there are also, I don't have the linkage up on here, but there are also sessions that are published from the recent VMworld, which go into some of the more recent announcements over the last month or so. And a wealth of information available online, including some of the stuff that's available through events that you'll see in your region, such as this one. But the training doesn't stop there. We've covered off a particular layer of content around VMware Cloud on AWS, but please pop along to the AWS website and have a look at the other digital training courses that are available. So if you enter into your URL, aws.training, you can see freely available courses covering many topics, including database services, analytics, migrating and tiering storage, which is something that I covered in today's session, and many other topics on there. So please do pop along and see what services you might get to learn more about without investing time and energy on training. And then if you find that this is something that makes sense for your organization, then you please do go further into deeper and deeper levels. So thank you for attending this particular webinar about modernizing your applications and infrastructure, and in particular using the VMware Cloud on AWS service. At the end of this session, please do complete the survey and let us know what you thought of this particular session and of the event overall. And we're always looking for ways to improve it. So please do contribute your comments on how we can make this better for you again for next time. Thank you very much, and I think we have no time for Q&A, but hopefully you've been able to interact with our specialists online. And I'll hand back to Pauline if you're there.
Yes, I'm around. So thank you, everyone. We had really great questions. And for those who were not able to answer, we will definitely take it offline. So again, remember, fill out survey form. The recordings to the webinars will be sent via email. And don't forget that we do have other sessions available. The next one coming up is the purpose-built databases to modernize your applications by Blair Layton. And on the 11th of October, 2 really great webinars sessions. One is on Microsoft applications on AWS, and the next one, which is SAP modernization with AWS. Now, I'll end the session here, but I want to wish everyone a very good day ahead. Talk to you soon. Bye.